How do we get the sum of the first nth term of a particular progression, whether that of the arithmetic progression or that of the geometric progression? Let's begin with that of the linear sequence, which is our arithmetic progression. To get the sum of the first nth terms, sum of the first nth term equal to the number of terms you want to find its sum, to multiply by the first term plus n minus 1, our common difference, then this. For that of the geometric progression, the sum of the nth term is equal to this formula is applicable when the magnitude of the common ratio is greater than 1. If the magnitude is less than 1, we would have 1 comes first, since the magnitude is less than 1. When the magnitude of the common ratio is less than 1. The number of terms might be getting to infinity. So if this happens, it means that r raised to the power of n would also be getting to 0. So it means that our sum to infinity would be a 1 minus, since this is getting to 0, would have is 0 here, over 1 minus r. So this is 1 minus 0 is 1, so we have a over 1 minus r. So this is the formula to get the sum to infinity. Let's apply this formula and use it to solve problems. Let's begin with that of the arithmetical progression. Our first question says find the sum of the first 20 terms of the linear sequence. We have the sequence 1, 5, 9, 13, and so on. From here, we have our first term as 1. Our first term is 1. And if you look at that, you will see that we are not given the common difference. But let me list them out. We have 1, 5, 9, 13, and so on. We're not given the common difference. We can find the common difference by itself. We just pick one of the terms and find a term preceding it, and we find their difference. So let's pick 13. The term preceding 13 is 9. 13 minus 9 is 4. If we should pick 5, the term preceding 5 is 1. 5 minus 1 is 4. So this is the common difference, 4. So we have D as 4. Now we can find the sum of the first 20 terms. So this is number of terms according to this formula here. Number of terms over 2. So that is 20 over 2, which is 10. But let me show you. Let me illustrate that. 20 over 2. 2 multiplied by our first term is 1. Plus number of terms minus 1. That is 20 minus 1. Multiplied by our common difference, which is 4. Here we have 10 multiplied by 2 plus 20 minus 1 is 19. And 19 multiplied by 4, we have 76. 76 plus 2 is 78. So we have 10 multiplied by 78, and this is 780. So the sum of the first 20 terms of that linear sequence, our arithmetic progression, is 780. Let's take another question. The level of difficulty of this question is higher than the previous one, in that this question is very tricky. It says the sum of the first 10 terms of an arithmetical progression is 255. Find the sum of the next 20 terms of the progression, given that the sum of the first 20 terms of the progression is 1010. We're not given the first term here. We were not also given the common difference. It's necessary for us to get that. But let us first of all take a look at the question. The sum of the first 10 terms is 255. We're giving the sum of the first 10 terms. We're told to find the sum of the next 20 terms. If you look closely at this, you will see that the sum of the first 10 terms and the sum of the next 20 terms would give us the sum of the first 30 terms. To get the sum of the next 20 terms, it's going to be the sum of the first 30 terms minus the sum of the first 10 terms. It means this is our focus. We are to get this. You are not told to get the sum of the first 20 terms because you were given already in the question. If you look at the last line of the question, it says given that the sum of the first 20 terms. So you were not told to find the first 20 terms. You were told to find the sum of the next 20 terms. So that would be the sum of the first 30 terms minus the sum of the first 10 terms. So our focus now is to get the first term and the common difference. Then we get the first 30 terms. Then we subtract the sum of the first 10 terms from that. Let's go. Let's list out what we have. We have our sum of the first 10 terms as 255. If we should write its formula out, we have 10 number of terms over 2 from here. That's 10 over 2, we have 5. 2 multiplied by the first term, we don't have the first term, plus number of terms minus 1. 10 minus 1, we have 9. We don't have the common difference. We can erase this. We don't need that. This, we can just divide both sides by 5 to get rid of the 5. We would have 255 divided by 5. We have 51 is equal to 2a plus 9d. Let's look at the next few lines of the question. It says, given that the sum of the first 20 terms, is also equal to 1010. So we would have number of terms over 2. That is 20 divided by 2. We have 10. 2 multiplied by the first term. We don't have the first term. 20 minus 1, n minus 1. We have 19d. We don't need this also. We don't need this. So we can divide by 10 here. Divide both sides by 10. We would have 101 equal to 2a plus 19d. If you look at this, you can see that we have two linear equations here which we can solve simultaneously. Let me erase this. These are the two equations we have. We can solve this by elimination or by which other way do we solve? By substitution. Yes, elimination or substitution. Which method are we going to pick? Since the coefficient of a is the same in both equations, we have to add the coefficient. We can pick that of elimination to eliminate a. So we just subtract 101 minus 51. That should be 50 equal to 2a minus 2a is 0. So it's eliminated. And 19d minus 9d is 10d. So it shows that d is equal to 50 over 10. If we divide both sides by 10, we have 5. So d is 5. We can substitute this in one of our equations. Let's pick the second equation. We have 51 is equal to 2a plus 9d. Since d is 5, we have 51 equal to 2a plus 9d. 9d, that's 45. 45. Subtracting 45 from both sides, we have 51 minus 45 is equal to 2a. 51 minus 45 is 6. So a is equal to 6. If you divide both sides by 2, we have a equal to 6 over 2. We have 3. So we now have our common difference and we have our first term. Don't forget, our aim is to get the sum of the first 30 terms. So we can bring that here. Sum of the first 30 terms equals to number of terms 30 over 2, which is 15. 2 multiplied by first term, our first term is 3. So 2 multiplied by our first term is 6 plus 30 minus 1, which is 29, multiplied by d. D is 5. So we have this 15. 6 plus 29 multiplied by 5 is 151. So 15 multiplied by 151, we have 2,265. So this is the sum of our first 30 terms. Now to get the sum of the next 20 terms, which the question requires of us, which the question requires from us, we have from sum of the first 20 terms equal to sum of the first 30 terms minus, not sum of the first 20 terms, sum of the next 20 terms after the sum of the first 10 terms equals to sum of the first 30 terms minus sum of the next first 10 terms. So we have 2,265 minus 255. So here we have 2010. So this is the sum of the next 20 terms. What about that of the geometric progression? Let's treat some questions on that. This question is find the sum of the first 6 terms of the exponential sequence, also known as the GP. With the sequence, we have 18, we have 6, we have 2, and so on. So from this sequence, we have our first term as 18. Don't forget we're told to find the sum of the first 6 terms. We have our first term as 18. Let me write out the sequence. We have 18, we have 6, we have 2. So our first term is 18. Our common ratio is the ratio of one of the terms and the term preceding it. Let's pick one of the terms. Let's pick 2. The term preceding 2 is 6. So this, the ratio of this is 1 to 3. So this is the common ratio between 2 and 6, the third term and the second term. The common ratio between the second term and the first term, that is 6 over 18. Or some teachers will write 2 over 1. 6 over 18. We have 1 over 3 also. So this is the magnitude of the common ratio. Is this less than 1 or greater than 1? Yes, this 1 over 3 is less than 1. So it shows that we are going to make use of the formula. We have r equal to 1 over 3 and the magnitude of r less than 1. So we are making use of the formula 1 minus r is to the power of n, since r is less than 1. 1 minus r. So our first term here is 18. 1 minus r is 1 over 3 raised to the power of n here is 6. So we have raised to the power of 6. Let me change this bracket. Over 1 minus 1 over 3. So you should be careful here. So if we should solve this, if we are to solve this, we would have 18 1 minus 1 over 3 raised to the power of 6. We have 1 over 729 over 1 minus 1 over 3 subtracted from 1 over 3. We have 2 over 3. From here we have 18. 1 minus 1 over 729. We have 728 over 729 over 2 over 3. We can split this in this way. We have 18 times 3 over 2. Why is it like that? This is 18 divided by 2 over 3. This is the same thing as 18 multiplied by 3 over 2. So we have 18 multiplied by 3 over 2. Then 728 over 729. 18 divided by 2 is 6. It's 9, not 6. So we have 27 multiplied by 728 over 729. So if you should calculate this if you should put this into your calculator, we have 728 over 27. So this is the sum of the first system of that sequence. Let's step this up a little bit. This question says the third term of a geometrical progression is 63 and the fifth term is 567. Find the sum of the first six terms of the progression. Here also we're not given the first term, we're not given the common ratio. We have to get that by ourselves. You should have an idea of finding the nth term of a geometric progression before now. The link to that will be in the description below. We're told that the third term of the geometric progression, the third term is 63. 63. And this is the same thing as our fifth term is 567. And this is the same thing as from the formula. So from here, we can erase what we don't need. From the first equation here, we can get the value of a by making it the subject of the formula. So from here, we can have 63 equal to ar squared. Divide both sides by r squared. So we have a is equal to 63 over r squared. So we can substitute this in the other equation. We have here 467 equal to our first term is now 63 over r squared. R raised to the power of 4. So here we have 567 equal to 63 over r squared. Multiplied by r in 4 places. So r squared cancels 2 of the r's. We have 567 is equal to 67 r squared, 63 r squared. We can divide both sides by 63 to get the value of r. We have 567 over 63 equal to r squared. So 567 divided by 63 is equal to 9. So 9 is equal to r squared. To get the value of r, we take the square root of both sides. We have the square root of 9 equals to r. So r is equal to 3. Since we now have the value of our common ratio, we can substitute that here. So we would have a is equal to 63 over r squared. R is 3, so we have 3 squared is 9. 63 divided by 9 is 7. So we have our first term as 7 and our common ratio as 9. Don't forget the question says find the sum of the first 6 terms. So we are going to make use of the formula of the sum of the nth term of a geometric progression. Here we have a as 7 and we have the r as 3. So r here, the magnitude of r here is greater than 1. So we are making use of the formula sum of the first 6 terms equal to a r raised to the power of n minus 1 over r minus 1. So this is, the first term is 7, r is 3, 3 raised to the power of 6 minus 1 over 3 minus 1. So here we have 3 raised to the power of 6 is 729. 729 minus 1 is 728 over 3 minus 1 is 2. So we have 728 divided by 2. We have 364. So we have 7 multiplied by 364. This is equal to 2548. So this is the sum of the first nth terms. Let's talk about sum to infinity. Find the sum to infinity of the sequence 1 over 4, 1 over 16, 1 over 64, and so on. Here our first term is 1. Our common ratio is, we pick one of the terms, Tn over Tn minus 1. Let's pick the second term and the first term. So we have 1 over 4 over 1. This is 1 over 4. Let's try the third term and the second term. The fourth term and the third term. We have 1 over 64 over 1 over 16. This is 1 over 4 also. So our common ratio is 1 over 4. According to the formula, we have r as less than 1. The magnitude of r as less than 1. So we have sum to infinity equal to first term 1 minus the common ratio. So we have a is what? 1 over 1 minus r is what? 1 over 4. So we have 1 minus 1 over 4. This is 3 over 4. One over 3 over 4 is 4 over 3. This is the sum to infinity of that sequence. So hope you learned something from this video. If you find this video helpful, make sure you subscribe. You can click on the profile icon appearing on your screen now. Thanks for watching. See you in the next video.